If you've ever checked your guys' range cards and realized that they might just all be ASVAB waivers, well then you're in the right place. This is the Objective Rally Point YouTube channel where the mission is to educate on all things combat arms and preparedness related. This is going to be the first video in a series on tactics, techniques, and procedures to make you more lethal, but most importantly, more survivable on the battlefield. This video is going to be covering the mill relation formula and its use, more colloquially referred to as the WERM rule. So why do we need a range in the first place? Primarily, it's going to be for targeting purposes with direct fire weapons or indirect fire weapons. So this person is this far away, therefore I must hold this high above them. Alternatively, knowing where you are and being able to determine the distance to an enemy in order to affix their position based off of their azimuth and distance. Alternatively, being able to gauge the size and shape of the enemy formation to maximize effects on target, as well as avoiding any fracture-side incidents. So, two types of ranging. Primarily, we've got passive and active. While there are different ways of distinguishing between ranging, these are going to be the two broadest strokes that are the most intuitive. So passive ranging, it's going to be using freely available information to determine the distance between 2 points, whereas active ranging is going to use some type of emission or action to determine said distance. So, and few examples of passive ranging are going to be both triangulation and the WERM rule that we are discussing today, whereas active ranging is going to be laser range finding, pace counting, echo using sonar, or stuff like synthetic aperture radar is also a form of active ranging. Pros with passive ranging. It's typically more covert and less observable than active ranging, depending on the method used. However, it tends to, as a whole, be much slower than active ranging, less accurate because it's predicated on a human carrying it out correctly who also knows how to do it and is actually carrying it out and exporting more effort. Whereas active ranging as a whole tends to be faster, more accurate, but has the huge con of being much more easily observable. How is it easily observable? Laser range finding is invisible, right? Yes, but not really. It's only invisible to the human eye. There are plenty of sensors on the pure battlefield that are capable of detecting laser emissions. Some types of analog night vision can see laser rangefinders if they're in the appropriate near IR spectrum. Alternatively, many near IR cameras or even just defilmed DSLR cameras are capable of detecting these. There are also laser warning receivers equipped on many pure armor threats, to include many of our own. So, what is the WERM rule then? The WERM rule, also width equals range mils, more easily said, width equals range times mils measured, is a mathematical formula to use a bunch of geometry that you don't have to necessarily know to use this in order to figure out how far away something is. So, in order to solve this formula, we need to know emphasis on two of these three questions. How long, wide, or tall should my target be? So what are the known dimensions of my target? For example, an M1 Abrams is 7.93 meters in whole length. We also need to be able to answer how many mils does the target take up in my optic? So measuring the target that we observe with our optic, for example, 8 mils long. And finally, in some instances, we'll be working with set distances where we need to know how far away the target already is, and then we can determine one of the other two based off of that. That's typically only going to be useful in garrison where you are creating preset range cards. With that being said, here we're going to look at an example of one real quick. As you can see here, I have a list of threats and their known dimensions of the PLA, People's Liberation Army, ironically named, where if we take a look at the Type 99 series MBT, we have their known dimensions and we have set distances where we solved for our observed mills, meaning if the tank is at 600 meters, I should see 3.92 or just under 4 mils. Quick note before we leave this page, the military age male threats are normalized for the average height and shoulder width of a military age male in each nation. So Russian threats are going to be slightly taller, as are American threats. Now, if you need to build out one of these tables yourself, I'm going to link this down below. Feel free to use it. This section here is pre-formulated. All you need to do is copy it and paste it into whatever Excel tool you are using. So, what actually is a mil then? Why does this work? A milliradian, also known as an emrad or a mil, is an angular measurement defined as 1,000th of a radian. But then what is a radian? A radian is the angle subtended from the center of a circle which intercepts an arc equal in length to the radius of the circle. What does that mean other than a bunch of gibberish? This is the arc length. This is the radius. What this is saying is that when this equals this angle created is 1 radian. With this being our arc length, which is also known as a portion or an arc of a circumference. A milliradian or emrad or mil is 1/1000th of this. The reason we need to use this is because over great distances, the further out you go, the longer the radius, the greater the arc length, and the larger the terms that are being discussed. So what units are we going to use for ranging? These are the ones that work. Here are the formulas for you if you need them. However, pay special attention to the one in the bottom left as the one we are typically going to be using in the military, where most of our maps, most of our reticles are going to be most conducive to measuring in meters for distance and for targets. That being said, all of these, with the exception of our kilometer-meter relation, have a constant. Pay special attention to that. If you do not use said constant, you will get a drastically inconsistent number. So D equals T over O times 1,000. D is going to stand for our distance to target. This is going to be the most common way that you lay it out because typically you are solving for distance. You want to know how far away that thing is. T is our known measurement of our target. So its whole height, width, length, doesn't matter as long as it's the same as the measurement that we are actively measuring through our optic. We need the same dimension. O is going to be our observed measurement of the target. So how many mils or emrads long is it or tall? So if you need to set something up on your own, just like I showed you earlier, this is the formula you would use to do so. If you need to isolate for another variable, you just flip it around. That's the formula for it. However, this is useful if you have a different set of threats that are going to be in the area than what I provided you, and you need to input heights, lengths, widths at set distances. Alternatively, if you know you're going into an area with set structures, let's say you know how high a window on a target building is, or how high the average cattle guard fence is in an area, or a ranch fence. you can go and you can create that out for your area of operations before you go in. So, how do we actually use this in practice? First things first, always you have to identify the vehicle you're dealing with. So, in this case, we have a BMD2. We know that our BMD is 2.45 meters tall, it is 2.94 meters wide, and it is 7.85 meters in length. Then we take whatever dimension we're going to be working with. In this case, it will be whole length, and we measure that. So we have the BMD stretching from 0 mils to 20 mils, meaning it is approximately 20 mils in length. I say approximately because it doesn't line up perfectly, and we also see that our BMD is at a slight angle here, meaning that that can skew our dimension of that. It's as simple as plugging into the formula, solving, and here's an example of if we did not have our constant to multiply, we would get some gibberish out that means nothing. In the case of meters, it's an easy move the decimal place over a few digits, and we get 392.5 yards. Again, I cannot stress enough, this is the accuracy of this is predicated on your accuracy of measuring how many mils you see in your optic, as well as your ability to actually perform the math. And many rules carry a calculator for just that reason, or calculating the size of charges. Do the math. So, again, why does this matter? Ranging is going to offer you a more complete and accurate view of the battlefield. Having a mental picture or a physical description on a map of where things are. This is going to be for both targeting as well as preventing fratricide, having pre-planned reinforcement routes, preparing positions, but the key thing being the future of pure conflict is going to complicate things like this that were originally simple and mundane. For the past 20 years, we have gotten used to just pointing a laser rangefinder at something or tapping 2 points on BFT and figuring out how far apart they are. This won't be the case any longer. As we face pure threats or even non-pure threats, as our average folks get night vision or get special laser warning receivers, or even just take the film off of a DSLR camera sensor to be able to see this. We need to start reducing our signature footprint in all spectrums, not just visible light, but near infrared, sound, and our radio emissions as well. Avoiding putting out emissions into the world is how we become more survivable. This isn't the only skill where we're going to see a resurgence of more passive or covert skills, as we need to shift to this pure threat mindset where we're not going to be owning the battlefield anymore. We need to fight for every inch of it. So, in closing, if you found any of this useful, please take it, please steal it, please get it to anyone who needs it or could benefit from it. Additionally, don't stop learning. Find something to do, find something to improve, whether it's worm rule this week, land nav next week, if it's actually gaining dope on your rifle or figuring out video editing. As you can see, I am doing my best for, and I will improve quality in the future, but pick something every single week, if not every single day, to either get better at or learn from scratch. Sewing, writing, photography, all of these have applicable skills in real life.